Hello and welcome to Tech Takshila's mock system design interview series.
In this segment, we showcase what happens in an actual system design interview session. So we hope that this will help you folks to get a better feel of what happens behind the curtain.
Awesome, so let's go ahead and get started. Hi Bob, this is Alice. Nice to meet you.
Hi Alice, nice to meet you too.
Okay, so we have this time reserved for your system design interview. Are you ready?
Yeah, I think so. I'm ready.
Cool. Have you used Uber or Lyft or any other ride hailing apps recently?
Yeah, I did. As a matter of fact, I took one Uber to come to this office location this morning.
Great. So you must know what happens whenever you book a ride through Uber on your mobile phone.
Yeah, pretty much.
Okay. So you must be aware that Uber first gets your GPS location and then matches you with a driver who is also in your local area. And then finally the ride gets booked and the driver drives to your location to pick you up and drops you off at a location. So the question for you is how Uber does this matching between a rider and a driver? Like what the flow would be, how the data is used, and what the user interaction looks like. So please use the whiteboard for explanation and drawing purposes.
Okay, so first let me write the question here. We are designing a service for Uber that books a trip for riders. Is that correct?
Yes, that sounds about right.
Great. So we will start by defining the requirements first. This will help us to be on the same page about what our service will or will not do. All right, so basically, we are just trying to develop the right booking experience for Uber users. We are not interested in trip completion like payments and stuff right now.
Yes, that is right.
So we will only focus on the trip booking part, and anything else we will put it in the outer scope or future enhancements. So the first requirement will be just like in Uber, riders should be able to look at what the potential drivers are there in the local area.
Okay.
And the second requirement could be that riders should be able to book the ride from their own device.
Okay.
Third requirement that came to my mind is could the rider be able to see ETA for the drivers to arrive in?
I think we can focus on the first two for now, since calculating ETA and showing it to users could take a little longer for us to design in the given time frame. What else can you think of?
Well, will our service be tracking the ride once it is started or rider has been picked up? Or will our service be able to book pool or shared rides?
Hmm. Let's put that also in out of scope for now.
Okay, sounds good. So for these two requirements, let's first see how it will look at a high level, like how and what different components we will need to build this feature entirely. So we will start with our users first. In our case, we will have two sets of users. One is the riders and the second one would be drivers. So drivers on their phone essentially will be interacting with our service, which we can call as the location manager. So this is our service. We will call this as location manager. And what this service will do, the main function for this service is to track the real-time location for different drivers in service in any geographical location. So this driver would be transmitting his or her latitude and longitude information with some metadata, let's say time and their user ID. Sorry for my bad handwriting, but it should be pretty clear that these are the coordinates and there are some metadata. So for example, we can have this sample map with some sample drivers who are driving in the location. So their mobile phones will be emitting their longitude and latitude at 1 second interval. Let's assume that for now. And also this gets stored in some highly scalable, very fast data store by our location manager service, which we will talk about in a bit. So we'll just put the placeholder for now.
Mm-hmm. Do you have any ideas for this data store?
We can get to that in a minute. It would be easier to first complete the entire architecture diagram for a rider's perspective as well.
Yes, that sounds about right.
Okay, so now let's talk about the riders. So for riders, as soon as they open up their app will again talk to the location manager service, which will query this data store for driver's location and return a list of drivers that are closest to the rider and show the dots on his or her mobile phone.
Okay, that looks good. But can you explain a little bit that how this location manager is finding the drivers in vicinity?
Yeah, so this is like sort of a graph problem where we can think of drivers and riders location as vertices on a graph. So let's draw it a bit. So we have these dots here, and so let's say that this thing is our driver and this guy is our rider. So we can apply like any graph algorithm here to basically find the shortest distance between the driver and the rider. For example, like Dijkstra algorithm. Obviously, we can go in a lot more detail on how to scale this piece, but that it can handle the real world traffic. This would essentially mean dividing the entire world's map into small cells and storing each rider and driver's location in small chunks after doing the pre-computation. So we'll have this map and then this will be divided into small cells.
Mm-hmm. Yep, you're right. Well, let's not deep dive into it. Let's continue with the design. Can you now tell that what sort of data store were you going to use?
Yeah, sure. So I think that we can use a NoSQL data store here, but we might need to do our own sharding in our case. As I was earlier mentioning that we need to divide the driver's locations into cells and then store that in a distributed manner.
Mm-hmm. Can you elaborate a little bit?
Yeah, so as we would have this longitude and latitude and potentially a driver UID to identify this, which driver's location is this, potentially a driver's UID to identify which driver's location is this, we would have two functions. We would need to add the new driver's location each second and remove the old one from this data store. So every second we are doing n writes and n reads. N is based on the number of drivers online in our case.
Okay, makes sense. Can you summarize the properties for this data store?
Yeah, sure. So this data store should support high writes and read load. It should support ephemeral data. It should also have low query time, and then we can apply custom sharding to scale out the data store. Since I'm hoping that when there would be a search, we might need to scale up or down these cells that we have drawn here.
Mm-hmm. Yep, that sounds correct. Now, can you complete the ride booking experience as well?
Yeah, sure. So once the rider presses a book button on his Uber app, we will have another service that we call as Trip Booker here, which will do the actual booking for us.
Okay, what would this service do?
So basically, it will try to match the rider with another potential driver based on the destination, rating, driver's preference, to name some of the factors.
Okay.
But essentially, this service will again query this locations manager to fetch all the latest nearby driver's location. It will then sort of create a ranking based on the factors that I just mentioned.
Okay.
And based on that, it will return the winning driver's ID back to the rider's phone to notify that the ride is booked. It will also send a notification to driver's phone at this point, and we will track everything the booked ride in a separate data store that we can call like ride book index or ride database.
There might be a minor bug here. Can you find it?
Let me see. Well, we haven't really talked about like the surge in traffic and scaling these services. So if there is like any extra amount of load that came with the ride request, it might basically overwhelm our system and the services might break down.
No, I was referring to that once a driver has been booked with a ride, we might need to stop tracking his or her location through this location manager. Otherwise, we can run into the danger of rebooking for this driver with another rider.
Oh, I see. Yeah, you're right. So basically, we may mark this driver's location as like on trip. So when we would query this through location manager, we would ignore the set of drivers location. So we can add like another field here is like is booked or not for each driver.
Yep, that's correct. Can you quickly suggest an enhancement?
Yeah, as I was saying that we like our location index might need to support high write and read load. So what we can do is we can use a Redis cache cluster between the actual location index and the location manager service. So instead of directly talking to the database for the car location, we can basically put a Redis based cluster here, cache cluster, and then our reads will happen via Redis cache cluster, and we will sync that from the car location index.
I see. That makes sense. As the reads would be higher in the number, as there can be many riders trying to get all the drivers' latest location every second. So it would be efficient to divide a read and write traffic.
Yep, that's right.
Well, all right, Bob. It was nice knowing you. I hope you have a great interview session after this. Best of luck.
Thank you so much. It was good to have your acquaintance.
So friends, we hope you enjoy this new video in our mock system design interview series.
If you're interested in seeing more of these videos, don't forget to subscribe to us and hit the little bell icon to get regular updates.
You can also check out other playlists to see basic system design videos or system design case studies. Also drop us a like if you like this video or use comment box for any suggestions.
Also visit our website www.techtextula.com if you like reading text over watching videos.
Until next time, keep practicing and best of luck. We'll see you in the next video.